Today we're at the Plumbing Industry Climate Action Centre looking at geothermal heat pumps. Here at the facility we have 3 demonstration systems. We have 2 water loop systems from Bosch and a copper loop refrigerant based system from Earthlinked. We'll be running through and giving you a bit of an overview as to how these systems work and what they do and why they're so efficient. Also at the facility here, at the Occupational Health and Training facility, we have 3 working copper loop Earthlinked systems, which we'll also be running through and giving you a look at. Here we have 2 Bosch water loop systems that are able to use 90 metre to 120 metre loops going down into the ground in high density polyethylene pipe, circulating water into the ground to pick up thermal differential between what the constant temperature of the ground is and what the ambient temperature at the surface may be. This is a water-to-water heat pump which allows us to circulate water down into the ground and back up to the heat pump, again exchanging that thermal differential with the water with the ambient temperature at the surface, and to provide heating or cooling effect into water that can be utilised in various applications within an office building, a domestic or residential application, or in fact even some industrial purposes. This system here is again a water loop system. This is a water to air heat pump. This allows us to exchange the thermal differential in the ground through water to come back up and then transfer that hot or cold energy that's been gained into air for air heating or cooling, again for residential or industrial or commercial applications. This is the water to air heat pump from Bosch, which allows us to demonstrate how we can generate reverse cycle heating and cooling using the constant temperature stored in the ground through a water loop system. We simply pump the water down into the ground through this loop. It will come back up, be circulated back up through this loop, and the temperature differential can be captured and transferred through a compressor and air handling unit to provide heating or cooling into a given space. These are the Bosch water loop systems, which can be used for commercial and industrial applications, as well as in some cases domestic purposes. There are several different ways we can harness temperature differential through water loop systems. In fact, some are what we call open loop systems, where we drill down into the ground with an injection bore and pump water down into the water table, and an extraction bore where we draw water back up and we use the thermal difference that's been captured by the water exchanging temperature differential into that aquifer or into that body of water, and these heat pumps can run on that basis. They can also be what we call pond loop systems, where we can simply use a high density polyethylene pipe system and slinky that up and put that in the bottom of a body of water and allow that body of water to enable us to transfer our energy into heating or cooling applications. And of course there's where we drill the holes into the ground, where typically for these water loop systems we would be drilling down between 90 to 120 metres in about 150 millimetre diameter borehole, and we would be putting down high density polyethylene pipe and running water, circulating water through that pipe work and capturing the thermal difference back at the surface at the heat pump to transfer into, in this case, water heating applications, to transfer this into hot or cold water heating or cooling, and for obviously air sourced heating and cooling also. This is a direct energy earth-linked copper refrigerant loop geothermal heat pump system, and it consists of several components. The first component is the copper loop that goes down into the ground. These loops are typically drilled into a 75 to 100 millimetre diameter borehole. The loops come in a 30 metre coil. They're uncoiled and fed down into the ground and grouted into those holes with a thermally conductive plasticized cement, which allows thermal conductivity between the refrigerant inside the copper loop through the grout into the ground and vice versa. These systems are reverse cyclable. They can heat and cool and provide a very, very wide array of different applications. The system that we're looking at here is designed to demonstrate reverse cycle ducted heating and cooling, and also domestic water heating or water heating for hydronic floors or radiant wall panels. The water side of these systems could also be reversed where there are water chilling applications. The heat pump itself, this is a 10.5 kilowatt heat pump. Here in Victoria, we get 3.5 kilowatts of thermal productivity for each 30 metre ground loop that we put into the ground. And that enables us to have very, very, very efficient heating and cooling processes, with the ground doing a lot of the condensing or evaporating of the refrigerant for us with no electricity or utility cost. And we'll demonstrate for you the ground loop system here in a moment. The heat pump itself will operate with very, very minimal amount of electricity, enabling us to save greatly on the utility cost for space heating and cooling and water heating or cooling. This is our hydronic or domestic water module, and it consists of a circulating pump that circulates water between our buffer tank or our tank that allows us to bring water up to an appropriate temperature. It also consists of a brazed plate heat exchanger, which allows us to transfer very, very, very economically heat produced by the heat pump into water or cold energy for water cooling applications. These heat pumps will operate as much as 80% more efficiently than conventional technologies for heating water for domestic and commercial applications. Very, very, very economical to run, and they provide very, very, very high degrees of heat exchange through the brazed plate heat exchange process. With respect to the air handling side of the geothermal heat pumps, it's actually no different to any conventional air handling management system. We use exactly the same fan coil units and air delivery systems that are used commonly in residential and commercial applications throughout Australia, and with a very, very minor modification, most conventional technologies can be adapted to be linked up to a ground sourced heat pump or a geothermal heating and cooling system. The heat pumps themselves, as you can tell, are very, very quiet. They operate with very, very, very minimal noise, and they also don't need to be ventilated. So they can be designed by engineers and architects to be incorporated into the building design rather than being external additions to the property. So there's some flexibility and some additional benefits on top of the extremely high energy efficiency in running these systems. There are a number of patented components within the heat pump itself, but the majority of the refrigeration technology in here is very, very basic and very been around for a long, long time. Very, very reliable system. There are very few moving parts and things that can go wrong. So service and maintenance is reduced compared to some of the technologies that are available today. The compressor itself obviously is what's driving the refrigerant through the system in its startup phase. And once the refrigerant's up to velocity, it's actually travelling through the earth loop component under its own velocity, and ensuring that oil's migrating back to the compressor for the compression system to operate effectively. The refrigerant control processes in the earth-linked heat pumps are unique and incredibly efficient. They do a very, very, very good job for both heating and cooling applications. The ground portion of our heat pumps is very, very robust and very, very stable in the ground. As you can see here, this is a 3-loop system, so there are a pair of 3-loop manifolds that are enabling each of the 3 30-metre loops to provide heating and cooling capacity to the geothermal heat pump system. The ground loops are very, very stable. If we're in ground where there is a high acidic content or perhaps saline soil where there may be a concern that over time the copper could be affected, we can engage a cathodic protection system that will allow an 80-year protection cycle for the in-ground copper portion of the system. Here you can see we have a 10.5 kilowatt reverse cyclable heat pump that's providing reverse cycle ducted or refrigerated heating and cooling to a lunchroom. It's also providing water heating for a bathroom, shower area, and of course the little kitchenette for the lunchroom area here. So this 10.5 kilowatt system is able to provide dual functions or 2 functions, and can heat water up to around 50 to 55 degrees Celsius as preheat to go into a conventional water system to boost it up to 60 degrees Celsius for the Australian standards. The capability of these systems to produce this water preheating is very, very, very efficient and can save vast amounts of money on high use or high water use facilities. But it's great to demonstrate here a system that can be doing reverse cycle ducted heating and cooling and water preheating for kitchen and bathroom scenarios. Here we have 2 geothermal heat pumps that are providing reverse cycle refrigerated ducted heating and cooling to an office and training facility. As you can tell, the heat pumps are very, very quiet when they're running and can take up minimal amount of space for compared to the size of conventional systems. This is an example where the heat pumps are located outside the building, but again, because these heat pumps don't require any ventilation, they can be incorporated into the design to be built into basements, car parks or closet spaces within the building design. This is an example of where a geothermal heat pump could be used right in the centre of an urban centre like Melbourne for, in this case, the application of swimming pool heating. Here we have a 14 kilowatt heat pump that's providing all year round heating for a fairly significant sized swimming pool, and also doing reverse cycle ducted and heating cooling for an on-site gymnasium. For this example, we've drilled in the garden bed here behind me, putting in 4 30-metre loops. And once the garden's reconstituted, you won't even know that the ground portion of the geothermal heat pump system's been installed here. So as far as everyone's concerned, this will be back to living as usual. This home's engaging 2 geothermal heat pumps for reverse cycle ducted heating and cooling over 2 levels, so one for downstairs and one for upstairs. It also has hydronic in-slab heating for the ground floor area, and we're also providing geothermally heated domestic potable water, so the domestic water for the buildings being heated up with the geothermal heat pumps also. So this is a great application of where the technology's been utilised to its maximum capacity to help reduce the payback period to as a quicker time as possible. So here are the 2 heat pumps for this property. We have a 14 kilowatt system that's doing reverse cycle refrigerated ducted heating and cooling in the upstairs level of the home. And we have a 21 kilowatt heat pump that is providing reverse cycle refrigerated ducted heating and cooling for the downstairs level of the property. The 14 kilowatt system is a dual function unit that is also providing potable water heating for the property. So it's heating the water for the showers, bathrooms and kitchens. And the 21 kilowatt heat pump is providing hydronic water heating for the floors. So this here is the hydronic buffer tank. So this heat pump will be able to, when it's not required to be air conditioning the space downstairs, can use the hydronic heat exchange module to produce hot water to feed into the floors for in-floor hydronic heating. Could also be used for radiant panels. The 14 kilowatt heat pump, its second function is the potable water. The potable water buffer tank is back here, and that's going through a gas boosted instantaneous system into the property to provide the potable water for the home. The 2 geothermal heat pumps at this property have a total of 10 30-metre ground loops going into the ground, and in this instance in the front yard directly beneath my feet. It's just easy to demonstrate with a property like this how this type of technology can be very, very easily and readily retrofitted to any urban environment throughout Australia.